In this podcast, we'll be going over how to calculate empirical formula from combustion data. Before we do that, I would just like to review what is the difference between empirical formula, written in short form as EF, and molecular formula. Empirical formula of a compound shows you the smallest whole number ratio of moles. So moles is the key word here. And molecular formula tells you the exact number of mole ratios of each element in a compound. So the difference between empirical formula is the smallest whole number ratio of moles, and molecular formula is the actual ratio of moles. For example, if you were to take C6H12O6 glucose, its empirical formula, you see everything's divisible by 6, will be CH2O, while its molecular formula will remain as C6H12O6. I would like to again remind you that these subscripts, or the numbers in either empirical or a molecular formula, indicate the mole ratios and not the mass ratios. Empirical formula has limited value because it only shows the relative ratio, but it is very easy to calculate. So generally, for an unknown compound, first we'll figure out empirical formula, and then if we know the molar mass of that compound, then we can figure out its molecular formula. So the question is, how do you figure out the empirical formula of a compound? And to figure out empirical formula of a compound, you have two ways in which you can do it. The first method for figuring out empirical formula of the compound that was discussed in the earlier part of this PowerPoint is from percent composition. So it's rather easy for chemists to figure out what's the percent composition of an unknown compound. And from percent composition, then they can figure out empirical formula. And then if the molar mass is known, then you can figure out molecular formula. The second method for figuring out empirical formula is from combustion data. So when chemists have an unknown compound, to figure out its empirical formula, they react it with oxygen, which is called combustion, and in the process turning all the elements in their oxides. And then they can analyze, and using mole ratios, they can figure out how many moles of each element were present, and then they can figure out simplest whole number ratio of moles, which is empirical formula. And from that, if molar mass is known, then molecular formula of that compound can be found. So there are two ways to figure out empirical formula. I'm going to emphasize in this podcast on the second method, which is figuring out empirical formula from combustion data. So what happens in a combustion data is generally most of the compounds are carbon-containing compounds. So we are looking for empirical formula of hydrocarbons. Hydrocarbons are made up of carbon and hydrogen, and when you burn them in air, meaning reacting with oxygen, carbon combines with oxygen forming carbon dioxide, and hydrogen combined with oxygen forming water. And if we could figure out how many grams of carbon dioxide was formed, then using mole ratios or stoichiometry, we can figure out moles of carbon dioxide, and that was using molar mass, and then using stoichiometry, we can figure out moles of carbon. Similarly, from grams of water, we can use the molar mass to convert it to moles of water, and from moles of water, we can figure out moles of hydrogen. And now, once you have moles of carbon and moles of hydrogen, all you need to do is divide them by the smallest number of moles and hope you get a whole number. If you get a fraction, you got to turn it to whole number. Remember, if it is a fourth fraction, then you multiply it by 4 to get a whole number. If it's a third fraction, then you multiply it by a 3 to get a whole number. If it is half, then you multiply it by 2 to get a whole number. any number, if you get a fraction for moles after dividing with smallest number of moles, then if it is less than 1.1 or greater, if it is less than 0.1 or greater than 0.9, then only you can round. Otherwise, if you get a fraction for ratio of moles, you got to figure out the whole number ratio, just like you've learned in algebra. That was the process for a hydrocarbon. If the compound contains carbon, hydrogen, and oxygen, carbon, hydrogen, and nitrogen, then another step is added. Carbon reacts with oxygen to form carbon dioxide, and then the process is same. Using gram of carbon dioxide, you figure out moles of carbon dioxide, then you figure out moles of carbon. Hydrogen will combine with oxygen to form water, and the process is same. You take grams of hydrogen, use molar mass, figure out moles of water, and from that moles of hydrogen. And the last process is, here you add one more step because you have nitrogen here, which when combined with oxygen forms NO2. So what will be the third step you'll add for carbon, hydrogen, nitrogen compounds? I'll write here. For nitrogen, you'll figure out grams of NO2. From that, using molar mass, figure out moles of NO2, and then using stoichiometry, figure out moles of N, and from that, you'll figure out smallest whole number ratio. And I will do a practice problem with you later in this podcast so you can actually see the process. If the compound contains carbon, hydrogen, and oxygen, now there's a little problem, because carbon will form carbon dioxide, nothing much changes there. Hydrogen forms water, with nothing much changes there. But now you have oxygen in the compound as well as added oxygen outside. How do you figure out amount of oxygen? In this, to figure out grams of oxygen, you will be given total grams of CHO containing compound. From that, if you subtract grams of carbon and grams of hydrogen, then that will give you grams of oxygen. So if from grams of CHO, which is total grams of compound, you get rid of grams of carbon and grams of hydrogen, that gives you gram of oxygen. Now, how might you get grams of oxygen? You will use the same method that you've been using, except you'll add one more step. From moles of carbon, you can get grams of carbon. From moles of hydrogen, you can get grams of hydrogen. And then you use that to plug in this formula. Now, this is a must-see animation, guys. If you look at this animation, you will see that the internet is rather slow, but you'll learn that you can select the gas here. It's for a hydrocarbon only, so you select your gas first, then you'll balance the equation, then you'll select amount of gas, you'll figure out moles and grams it'll actually give you, and you start the reaction here, and it'll tell you how many grams of products are formed or how many moles of products are formed. So you can actually do this calculation, choose any gas, balance it, and then check your calculation by looking at the values here. And just to show you how this process works, this is actually the equipment. So this is called calorimeter, where you burn a sample of unknown gas, meaning you combust it with oxygen, and then you form carbon dioxide, and you pass it through something called as carbon dioxide absorber. Generally calcium hydroxide or calcium oxide is used for this purpose. And then you have water absorber, which is generally calcium chloride is used for this purpose. Now, how you would do is, you would put a weighed mass of calcium hydroxide in this chamber, and after passing the carbon dioxide, you'll see the increase in mass. So increase in mass is carbon dioxide's mass. Similarly, you've put a weight quantity of calcium chloride and water absorber, and increase in mass will indicate the mass of water. So this was the theoretical background behind empirical formula from combustion data. Another thing to remember here is, complete combustion produces carbon dioxide, but if it is incomplete combustion, it will produce carbon monoxide as well. So in an incomplete combustion, you'll make carbon dioxide plus carbon monoxide, while in a complete combustion you'll produce only carbon dioxide. Now let's do a problem together. Many homes in rural America are heated by propane gas, a compound that contains only carbon and hydrogen. Complete combustion of sample of propane produce these many grams of carbon dioxide and these many grams of water. Find the empirical formula of propane. So you're given 2.641 grams of carbon dioxide and you're given 1.422 grams of water. What might your thought process be? Ultimately, what do you need? You need moles of carbon and you need moles of hydrogen. So you'll use molar mass of carbon dioxide to convert 2.641 grams of carbon dioxide to moles of carbon dioxide. Once you have moles of carbon dioxide, you know in 1 mole of CO2 there's 1 mole of C. That will be same as moles of carbon. Similarly, you'll use the molar mass of water here to get moles of water, and then you will multiply moles of water by 2 to get moles of hydrogen. Why would you have to multiply moles of water by 2 to get moles of hydrogen? Because in 1 mole of water there are twice as many moles of hydrogen, H. In 1 H2O there are 2 H's. And once you get the moles of carbon and moles of hydrogen, you'll take smallest moles, whichever is smaller, carbon or hydrogen, and divide all moles by this. And if you get a whole number ratio, that's fine. If you get a fraction, you got to convert it to whole number. Do this problem on your own and see if you get the answer. If not, you can always email me with your questions and I'll be happy to walk you step by step. The next one is similar type of problem. Here, in addition to empirical formula, they're asking you to calculate molecular formula and they've given you molar mass. So you'll need to add one more step. Once you calculate empirical formula, you'll see empirical formula mass, which is the mass of empirical formula. So what will be empirical formula mass for C3H4? It'll be 3 times mass of carbon plus 4 times mass of hydrogen. So it'll be about 40 grams per mole. And you know, if it is the molar mass is between 115 and 125, what are the multiples of 40? You know, I would say times 3. So if you times this 3, what's the formula you get? You get C9H12. So that's how you convert empirical formula to molecular formula. To convert empirical formula to molecular formula, you need this N, or a small number that you multiply empirical formula by. So to get the N, you take molar mass and divide it by empirical formula mass. And once you get the N, if you multiply your empirical formula by N, you get the molecular formula. And in this problem, the compound contains carbon, hydrogen, and oxygen. So how's this problem different? In addition to having carbon and hydrogen, you also have compound containing oxygen. So what will be your thought process? Little different. First, you'll need to figure out from grams of CO2 to moles of CO2 to moles of C to grams of C. My question to you is, if you needed grams of carbon, why couldn't you go straight from grams of carbon dioxide to grams of carbon? Answer is because there is no connection between gram and grams. Stoichiometry works only between mole ratios. So you have to convert grams to moles and then moles to carbon, figure out stoichiometry, and then convert it back to grams of carbon. Similarly, what you'll do is take grams of water, change it to moles of water using molar mass, using stoichiometry, change it to moles of hydrogen, then convert it to grams of hydrogen. Now you're given the total mass of the sample, so gram of oxygen will be equal to 0.2500 gram minus gram of carbon minus gram of hydrogen, and that'll give you gram of oxygen. Once you have all the 3 grams, you'll convert this gram of carbon to mole of carbon. You'll convert gram of hydrogen to moles of hydrogen, and you'll convert gram of oxygen to moles of oxygen. Once you have all the 3 moles, you divide all the moles by the smallest moles, and if you get whole number, then that's your empirical formula. If you don't get whole number, you got to multiply it to get a whole number, and that'll be your empirical formula. And that was all for Empirical Formula Podcast. Thank you for listening.